Hey, what's up, guys? It's Nicola from Calcunic, and today we're going to talk about the chain rule. Let's get right into it.
So the chain rule is one of, if not the most important derivative rule that you'll learn. And if you plan on studying any science, engineering, or math, you'll definitely come across it many times. And so the chain rule helps us to solve the derivatives of composite functions. Now, when we say composite functions, we mean functions that look like this, say f of g of x. In this case, we notice that the input for f isn't x, but it's another function, g of x, and we call these kinds of functions composite. So to take the derivative of these, there's not an easy way unless we use the chain rule. And so the chain rule says that the derivative is equal to f prime of g of x, or the derivative of f, just a different notation, and times g prime x, so the derivative of g. We would want to use a chain rule for a question like this, say 2x plus 1 to the power of 4. This is because there's one function on x inside the brackets. We're multiplying it by 2 and adding 1. But there's also a second function. We're taking the fourth power. So this is a composite function, and we need the chain rule to solve this. On the other hand, if we had a function like x cubed, in this case, we don't need the chain rule because the cube stands alone. It's the only function on x, and therefore we could use a simple rule like the power rule. Now that we know the chain rule, let's try to apply it to some other problems. Let's try the problem from before. So we have the derivative of 2x plus 1 to the power of 4. And to solve this, we need another rule, the power rule. And for those of you that don't know, I'll just write it out here. The derivative of x to the n is equal to n times x to the n minus 1. And so what we do here is we take the exponent, bring it out to the coefficient, and then reduce the exponent by 1. And so for this question here, we identify the two functions on x. First, the inside one, we have 2x plus 1, and on the outside, we have to the power of 4. And so when we use the chain rule, first we want to work with the outside function. So this is equal to, using the power rule and chain rule, 4 times 2x plus 1, because the inside stays the same, and the exponent gets reduced by 1 by the power rule, so we have to the power of 3. And now if we take a look at the chain rule, what we have to do is multiply by the derivative of the inside, and the derivative of 2x plus 1, well, that's just 2. And by rearranging, we could get 8 times 2x plus 1 to the power of 3. Next, let's say we have the derivative of 1 over 3x plus 5 to the power of 3. And for this, what we're going to do is move the denominator to the numerator. And so the exponent becomes negative. So we get the derivative of 3x plus 5 to the power of negative 3. And now we see we have our inner function here, 3x plus 5, and the outer one, we're taking to the power of negative 3. And so by using the chain rule, first we take the derivative of the outer function. We have minus 3 times 3x plus 5. And the exponent gets reduced by 1, so we have minus 3 minus 1, that's minus 4. And we multiply this by the derivative of the inside, 3x plus 5, and that's just 3. And by rearranging, we get minus 9 times 3x plus 5 to the power of negative 4. Now let's say we have the derivative of the square root of 7x minus 2. And so for square roots, usually what you want to do is move it into an exponent. And so the square root is the same as saying taking the inside and putting it to the power of 1/2. So 7x minus 2 to the power of 1/2. And now using the chain rule and power rule, we have 1/2 times 7x minus 2, and the exponent gets reduced by 1, so negative 1/2, that's 1/2 minus 1. And times the derivative of the inside, 7x minus 2, and the derivative of that is just 7. And so by rearranging, we get 7 over 2 times 7x minus 2 to the power of negative 1/2. Let's try some examples with trigonometry. So let's say we have the derivative of sine of x squared. And so in this case, our inner function is taking x to x squared, and our outer function is sine of x squared. And so for the chain rule, first we want the derivative of the outside function. And so the derivative of sine is just cosine. And then the inside stays the same for now. And we multiply it by the derivative of the inner function and the derivative of x squared. That's just 2x. And so by rearranging, we get 2x times cos x squared. Now, if we had a expression like the derivative of cosine times sine of x, pretty similar. We have our inner function sine and our outer function cosine. And so the derivative of this using the chain rule is first the derivative of the outside, and the derivative of cosine is negative sine, and the inside stays the same, so we have sine x, and we multiply it by the derivative of the inside function, in this case sine, and the derivative of sine is going to be cosine x. And so by rearranging, we could write that this is equal to minus cosine x times sine of x. Let's try another now. We have the derivative of tangent squared of x cubed. And so in this case, what we want to do is move the squared on the tangent to the outside just for visual clarification purposes. So we have tangent of x cubed, and all of this is squared. So these two are equivalent. That's what you could do when you have tangent squared. You can move it to the outside. And we can see here that we actually have three functions on x now. We have x cubed first, then tan of x cubed, and then we're squaring that entire result. And so we're actually going to have to do two iterations of the chain rule to solve this. And so first, our first one is going to have to deal with the very outside function, so the squared. And so how we do that? Well, we take the 2, bring it out front. We have 2 times the inside stays the same, of tan x cubed. And the exponent on this is going to be 2 minus 1, or just 1, so we can omit it. And we multiply this by the derivative of the inside, tangent of x cubed, the derivative. And so this is equal to, this stays the same, 2 tan x cubed. And we multiply it by first the derivative of tangent, because that's the outside function. The derivative of tangent is secant squared, and the inside stays the same, so secant squared of x cubed, and that derivative is 3x squared. So by rearranging, we could write this all nicely as 6x squared times secant squared of x cubed times the tangent of x cubed. Let's try some derivatives with the natural logarithm. Let's say we are asked to find the derivative of ln of 3x plus 5. And so once again, we have our two functions on x. We have first 3x plus 5, then ln of all that. And if you don't know, the derivative of ln of x is known to be just 1 over x. And in this case, so first we take the derivative of the outer function, in this case ln, so we'll get 1 over the inside, 3x plus 5. And we multiply this by the derivative of the inside function, 3x plus 5, in this case just 3. And so this simplifies to 3 over 3x plus 5. Let's say we have the derivative of e to the 2x plus 3, and then all of that squared. And so first our innermost function, 2x plus 3, and then we're squaring that, and we're also taking that number and taking e to that power. So in this case we have three functions on e, and if you don't know, the derivative of e to the x is probably the easiest derivative. It's just e of x, so that nothing changes there. And so since we have three functions in x, we'll have to use the chain rule twice. And so first we use it on the outermost function, in this case e. And so the derivative of e to an exponent is just e to that exponent. So we have e to the 2x plus 3, that stays the same, squared. And now we want to multiply this by the derivative of the inside function, or what's in the exponent. And so this is equal to e to the 2x plus 3, that stays the same, squared, times the derivative of this function. And so here we use the power rule and chain rule and get that the derivative here is 2 times 2x plus 3 to the power of 2 minus 1, or just 1, so we can leave that out. And we multiply it by the derivative of the very inside function, 2x plus 3, which is just 2. And so rearranging, we get that this is equal to 4 times 2x plus 3 times e to the 2x plus 3 squared. Let's say we're asked to find the derivative of a product of functions. In this case, 5x minus 3 times 4x minus 1 to the power of 5. And so because we have a product, we need to use the product rule. Now, because we have a slightly bigger expression here, we'll write out all the intermediate steps first to simplify our calculating. So let's say f of x is equal to 5x minus 3. In that case, the derivative of f of x is equal to simply 5. And let's say g of x is equal to 4x minus 1 to the power of 5. And then by using the chain rule, we get that the derivative of g is 5 times 4x minus 1 to the power of 4 times the derivative of the inside, which is just 4. And so the derivative of g of x is equal to 20 times 4x minus 1. And we'll refer back to these calculations, but now let's get started. So we have the derivative of this. First is the derivative of f, in our case 5x minus 3, so just 5, times the g function, g of x, so we have 4x minus 1 to the power of 5. And we add this with f of x, so in this case 5x minus 3, times the derivative of g of x, so 20 times 4x minus 1 to the power of 4. So we see that we could factor a term of 5 times 4x minus 1 to the power of 4. And let's see what we have left. We have that 5, it gets canceled out, and we have that all that's left is one term, 4x minus 1. And on the right hand side we could cross out a 5 here, all we have left is 4, and this entire term goes away. So what we have left is, on the left hand side of the plus sign, 4x minus 1, and then on the right side we have 4 times 5x minus 3 left. If we reduce now, we get 5 times 4x minus 1 to the power of 4 times 4x minus 1 plus 20x minus 12. And finally, if we group like terms, we get our final answer. Here we have 4x plus 20x, so 24x minus 1 minus 12 minus 13. And so 5 times 4x minus 1 to the power of 4 times 24x minus 13. Let's move on to our final question. We're asked to find the derivative of 2x plus 1 cubed divided by 3x minus 2. And so to solve this, we need another rule. We need a rule called the quotient rule, which tells us that the derivative of the division of two functions, call them f of x and g of x, is equal to this. And so to solve this, we need to identify our two functions f and g. So we'll start with f. We have f of x is equal to 2x plus 1 cubed. And the derivative of f of x, well, we use the chain rule. So we have 3 times 2x plus 1, and reducing the exponent by 1, we get 2, times the derivative of the inside. So the derivative of 2x plus 1, well, that's just 2. And this is equal to 6 times 2x plus 1 squared. And we have our second function, g of x, which is equal to 3x minus 2. And the derivative of g of x is a bit more simple, it's just 3. And so now we actually want to go and solve this. So in the numerator, we have f prime x times g of x. So 6 times 2x plus 1 squared times 3x minus 2. And we subtract this with f of x times g prime x, so just 2x plus 1 cubed times 3. And this is all over g of x squared. So 3x minus 2 squared. And what we're going to do here is group some like terms, take a factor out, and we see that there's a common factor of 3 times 2x plus 1 in the numerator. And so when we factor this out, we take a 3 out of the 6, and what remains is a 2. The entire 2x plus 1 squared term goes away, and we still have that 3x minus 2 left over. So we have 2 times 3x minus 2. And we subtract this with, well, here we take away squared 2x plus 1, so what remains is one of those, and the 3 goes away completely. So all that's left is 2x plus 1. And once again, this is all over 3x minus 2 squared. And so now, cleaning this up a bit, we get 3 times 2x plus 1 squared, that stays the same, times 2 times 3x, well that's 6x, and then minus 4, and here we have minus 2x minus 1, all over 3x minus 2 squared. And we move to our last step, which is finishing it up. We have 3 times 2x plus 1 squared times, and we group like terms, we get 4x minus 5 all over 3x minus 2 squared, our final answer.
Alright guys, thank you so much for watching. If you had any questions about the video or just other video suggestions, drop them down in the comments below. I do try to get to all of them. And if you liked the video, if you learned something, consider liking and subscribing. It would really help me grow my channel, reach a greater audience, and hopefully help more people with math. That's all from me. Till next time.